Hi, I'm Lamonte Garber, and I work for the Stroud Research Center, and I'm their Watershed Restoration Coordinator. And in that role, I work with farmers, primarily in southeastern Pennsylvania, on a whole range of water-friendly strategies and technologies. And I'm going to be kicking off our session today where we are talking about agriculture and water. And as most of you know, water is an absolutely critical issue to farmers, and the role of farming is absolutely critical to greater society as we meet a whole range of water-related challenges, be it pollution, be it flooding, be it habitat. Farmers are really playing a central role in how we address water issues going forward. And that is true for Pennsylvania, it's true for this country, and it's really true globally. But I'm coming to you today from the White Clay Creek watershed in Chester County, which just happens to be the home of the Stroud Research Center in Avondale. And this stream that's behind me here is one of the most intensively studied streams of its size anywhere in the world. The Stroud Center has been gathering in-depth data on all aspects of how this stream and the watershed that surrounds this stream functions for over 50 years. And we study a lot of other streams here in Pennsylvania, across the country, and in other parts of the world, but nowhere do we understand a stream better than right here in Chester County, Pennsylvania. And that's important for our work with the Watershed Restoration Group at Stroud, which is the part of Stroud that I work with, because when we go out to landowners and businesses and local governments who want to know how they should be managing the water that falls and flows through their properties, the way we approach this issue at Stroud is to try to understand how natural, healthy streams function so that we have a template for how to help people fix streams that are unhealthy, that are not functioning in the ways that they should be. The way we look at it is, if you want to understand how to fix a broken stream, you need to understand how a healthy stream works. And so we, along with other science institutions around the country, are looking at streams, rivers, and watersheds and wetlands to try to get a handle on the nature and extent of the problem, but also how these natural freshwater systems work and how we can apply that knowledge to restoration activities with people that really want to improve the quality of the water in their communities. So we really should start this whole conversation with a concept that hopefully is familiar to most of you, although you may be surprised to know that most of the people, or a majority of people in the general public, are not clear about what the term watershed means. And again, because many of you are working in this area professionally perhaps, you will understand that a watershed is that area of land that delivers rain or delivers water to a particular waterway through the water cycle, through rain falling on the land, flowing over the land and underground toward a particular stream, river, lake, estuary. That land that surrounds a body of water is called a watershed. And they're nested, so you have tiny little watersheds like this stream's watershed, which flows into a bigger watershed downstream and ultimately ends up in a massive watershed that is the Delaware River Basin, which then delivers fresh water out to the Atlantic Ocean. But watershed is so important to our conversation today because it really is important for all of us to understand that if we want clean water and if we want healthy streams and rivers, we really have to get the land right. It's not so much, we do need to address discrete sources of pollution, both from point sources, which are from pipes, and non-point sources, which is runoff. We obviously need to address sources of pollution that are flowing directly into a stream. But so much of what we need to do to have healthy streams and rivers is to actually go up on the land, work with everybody that is managing that land, be they farmers, foresters, businesses, municipalities, and assist all those different actors in fine-tuning how they are managing their little piece of a particular watershed to increase infiltration, to reduce polluted runoff, to reduce erosion, as well as many other aspects. And so this whole field of freshwater science and restoration is mostly about how we manage our watersheds better. So that brings us to the topic of agriculture. We obviously do all kinds of things that affect our watersheds, but agriculture just happens to be the biggest single human influence we have on the landscape. And so farmers, because they manage so much land, and because the way we manage land has so much to do with the quality of our water, farmers really can do a lot more per person to really change the quality of our waterways than really any other sector, right? Farmers just have so many resources at their fingertips, and if they get things right, they have a tremendously beneficial impact on our watersheds. But if things aren't managed so well on a farm, if there's high soil erosion rates, if animals like cows have access to the streams and they're degrading the riparian environment, if there's too many agrochemicals or nutrients that are applied on the land, if those things are not managed properly, then that same farm that might be an environmental showcase could actually be a real environmental hazard for water. And so we work with farmers in a voluntary way to provide them information, to provide them, in some cases, technical or financial assistance to really manage their properties in ways that make for abundant food production while also restoring our waterways and the watersheds that are feeding those waterways. So we are standing, again, near the White Clay Creek, but just upstream of the open meadow section. And this whole area that you see here used to be a cow pasture. Decades ago, when Stroud first established this research facility here, this was an active dairy farm. And the cows were removed, but what grew in this area was a lot of non-native shrubs that were a real problem. So about 25 years ago, the staff at Stroud planted all this area in trees, and they worked hard to get these trees to grow, and in fact have researched a lot about what it takes to get young tree seedlings to go in the floodplain, right? But now we have this beautiful new forest that's already transforming the stream that's behind me. It's transforming the stream in so many ways, and a big part of the research effort here at this particular stream is looking at what these trees do in various ways to change the stream environment. So we're actually evaluating the stream in 3 different land covers. That open meadow section that's fully sunlit with grass growing right up to the stream, this young forest that you see growing here, and then further upstream we have an old 100-year-old forest with big trees, and that stream has been flowing through that unbroken forest for many, many years. And what we find is that the stream that's flowing through just a grass area is very, very different from what you see in a forested setting. And in fact, we see so many different benefits that these trees are providing, from shade to cool the water, to large woody debris that falls in the stream and then becomes fish habitat, to the woody roots that anchor the stream bank. But one of the most interesting things that has been poorly understood until more recent years is the power of these trees to widen the stream channel back to a more natural profile, a much wider profile. In many places, the stream just here, just a few hundred yards upstream from the grass section, is 2 to 3 times as wide. Why is that width important? Well, clean water is important to everyone, right? And we do a lot of things, some of them very expensive, to keep our water clean. But streams are natural water treatment systems. They process a lot of the bad stuff that we put into the streams. And so many of those pollution reduction processes are happening on the bottom of the stream, on the stream bed, right? And the wider we can get that stream bed, the bigger the bioreactor we have for all those microbes to do their magic, to break down pollutants, to sequester pollutants, to transform pollutants like nitrogen into harmless nitrogen gas. So these trees are not only making this environment, this stream environment, healthier for fish and insects and all the other wildlife that depends on a cleaner stream, it's also turning this stream into a more effective water treatment system that's operating 24 hours a day, 7 days a week, sending cleaner water downstream to cities like Wilmington or Philadelphia, where people rely on surface water for their drinking water system. Okay, we're again in another section of the White Clay Creek at Stroud. This is the older growth, mature forested section. The stream is much wider. As you can see here, considerable large woody debris falling in the stream and creating habitat. This is a really, really healthy stream for southeastern Pennsylvania. And one thing I wanted to show you down here is the stream bed. These rocks that form the stream bed are where a lot of the action is in the stream. And if you could look really closely at this rock, what you'd see are lots of little mayflies and stoneflies crawling around on this rock, right? We call them macroinvertebrates, aquatic insects. And the reason that they are so important is that they are the canaries in the coal mine for our streams. They tell us whether a stream is fair or acceptable or excellent. We can do a lot of other sophisticated water quality testing, but I tell farmers, if you want to know how healthy or unhealthy your stream is, just go down to the stream on your farm, turn over some rocks, and see what's growing there. If you just see a lot of worms and fly larvae, you may not have a very healthy stream. Another reason why that's so important is that just like big estuaries like the Chesapeake Bay are impaired and they need to be restored, a lot of streams in Pennsylvania are also on DEP's impaired waters list. And we've got to get those streams restored just as we're trying to clean up places like Delaware Bay and Chesapeake Bay and the Gulf of Mexico. Well, we get those big water bodies cleaned up by fixing all the little thousands of miles of little streams that are flowing through them. And so when we help a stream like this, we're not only hopefully moving toward a time when a stream like this can be taken off of DEP's polluted waters list, and then at the same time we're sending cleaner water downstream. So much of the research that happens at Stroud, understandably, is water related. Chemistry, microbiology, entomology, geology, all kinds of different disciplines around how streams and rivers work. But because restoration in the watershed is so important to restoring the health of our waterways, Stroud also does quite a bit of research in the area of reforestation. Planting trees is easy. Getting those trees to actually grow from a small seedling to a mature hardwood actually takes a lot of work. And what we're trying to figure out is how to plant those young tree seedlings along streams on farms, but do so in ways that really optimize success of that final tree planting without being too much of a burden on the farmer and without being too expensive. This is just a demonstration area here where we can show landowners and practitioners different kinds of tree shelters that we use, different ways of controlling weeds. Like this is usually mowed in the summer. As these trees are getting taller, mowing becomes less of an issue or less of a need. But when these trees were very young, we were mowing this site constantly. So we're doing research on weed control, on rodent damage, on deer pressure, because these young tree seedlings will grow aggressively in Pennsylvania, but there's also a lot of other things that want to outcompete those trees or eat those trees. So we're trying to make this process of reforestation in these critical waterway areas as effective, but also as painless as possible. Another aspect of this site here is that we have installed what we call a level lip spreader below that cropland. It's between the cropland and the buffer. And what it does, it's a swale that infiltrates stormwater runoff so that we don't get a lot of rushing water that blows right through the buffer and to the stream. Instead, this swale spreads out that stormwater flow, infiltrates it, and if it's a really, really intense storm, it'll overflow that swale and flow gently into the buffer to maximize the filtering process that those trees can provide. So it's just one example of a kind of an additional step that we can take to really fine-tune the water management on a farm, but it does bring up the issue of land. Farms are based in large part on the amount of land base that they have to farm, be it cropland or pasture. And everything that we do like this in terms of planting a forested buffer or installing a new stormwater treatment installation, that's taking up land that a farmer might otherwise use to grow corn or to pasture livestock. And so while we are coming up with technical ideas for how farmers can modify their farms in ways that's good for the water, we also have to come up with financial and technical tools that make it affordable. We need to be looking at policies that will enable farmers to do this while staying in business. And we work with institutions like the William Penn Foundation and National Fish and Wildlife Foundation, not only to provide direct funding to farmers in some cases to do these, but also to be looking at innovative ways to expand the number of financial and technical tools that farmers might have. So instead of simply planting a forested buffer, could we also be including some species of productive, profitable plants that are part of this system? That might be one approach. Looking at some novel or alternative funding streams to complement those government programs that are already in place, that's also a really big need. So there's a lot of people that are working together on this water issue, a lot of different partners playing different roles, and we're just trying to bring the science world and the farming and practical world together to really make things as feasible as possible so that we can scale up these improvements as quickly and across as broad a landscape as possible. So we've moved upstream a bit from where we were talking before because we wanted to show you some farming practices that are some of the tools we can choose from when we're working with landowners to improve water management. We've got a number of different things right in front of us here, so it's a nice place. So right here we've got corn that's just been harvested, but this is a no-till field that is rotated into different crops. It is never plowed, and it's also planted in cover crops. So it's a whole series of crop management systems that improve the health of the soil that underlies the crops that grow here. A really, really critical set of practices, not only for good food production, but also cleaner water. And also carbon sequestration that's really, really necessary for climate change mitigation. Beyond that, that strip of green that you see there is what we call a grass waterway. So that's just one of the field practices that can be installed to capture runoff and take it slowly off-site, thus preventing soil erosion, right? And delivering clean water to the stream that's at the bottom of the hill. Then beyond that, you see those white tree shelters. That's a forested buffer we planted as part of a flood mitigation project. So we're establishing a forested buffer between the cropland and that stream that's just on the other side of those trees there. And finally, we can see some cover crop and soil health research that is happening here at Stroud. The field on the other side of that stream is part of a long-term study on the effect of using cover crops in a no-till agricultural system or not, comparing those two cover crop and non-cover crop systems to see what effect those two different treatments have on water quality. You're seeing just a handful of different farming practices that improve water quality while enhancing farm production, but there are many, many others. And every farm is different. Every single farm has different resources, different resource concerns, and the solutions are going to be different. And that's why it takes really knowledgeable people, be it conservation district staff or crop consultant, to be working with the farmer and maybe with a third party like Stroud or some other organization to really pull together lots of different options that the farmer can use to really make it a high performing situation. So with that, I'd like to just end with some thoughts about the new Bolton Center. We are so excited to be in discussion and conversation with new Bolton Center about their long-term vision for the future as they look at ways to modify and enhance the facility and all the pastures in the cropland to become that farm for the future that has such promise as both a research and education facility, but also a model for different kinds of farming practices that hold a lot of promise for clean water. We're happy to be part of that conversation and hope to contribute some ideas that we've generated both from our own research, but also our work with farmers across Pennsylvania. Thanks.